Alright guys, so today we're going to be talking about linear and nonlinear functions. So make sure you have this half sheet of notes out. It says linear versus nonlinear functions. Get them out, get them ready to go, because that's what we're going to be working on for about 5 to 10 minutes here. Alright, so first of all, linear functions. This is what we've been talking about for a long while now. It has the word line in it. And that's very indicative of what we're talking about. We're talking about lines. Linear functions are lines. So, when we talk about linear functions, we know it's going to form a straight line. And remember, our formula for a line is y equals mx plus b. And what's important to know about a linear function versus a nonlinear function is our x does not have an exponent. So there is a constant next to it, there's a number, but up top there's no exponent. And that's the most important part when you're looking at an equation. And the last way we can tell if it's a linear function or not, and I want you to star this one because I think it's very important. It has a constant rate of change. And so if it has a constant rate of change, that means it's changing the same amount. Alright, so we know it always has the same rate of change throughout. So an example, whenever we see it on a graph, we know it's a straight line. So if I give you the line y equals negative 1/2 x plus 2, just totally an example. I always start with the y-intercept, which is going to be my 2. We'll go up 2 and make a dot. Then I know my slope is next to x, negative 1/2. And remember our slope, negative 1/2, is those two R words, rise over run. So that means I'm going to rise negative 1, so I'll go down 1, and I'll run 2. 1, 2. Make my new dot. And right there, we have a linear function because it is a straight line. Our x doesn't have an exponent next to it, so we know it's a linear. And we have a straight line, so we know it's linear. Now next, we're going to write a linear function. We'll start with negative 1, 0, 1, and 2. Negative 1, 0, 1, and 2. Then over here, I just have these numbers already made up. We have 5, 3, 1, negative 1. So remember, when we're looking at a table, we want to look for if there is a constant rate of change or a constant slope. So remember, when we're talking about slopes and tables, we have change in y, we have change in x. So we want it to always be the same. So from our first one, I have a change in y of 5 to negative 3. How much does it take to go from 5 to negative 3? Well, a negative 2. Well, let's see if it's constant. What about from 3 to 1? Also a negative 2. Or 1 to negative 1. Negative 2. So it's always constant. It's the same, the same, the same. Then we're looking at our x. From negative 1 to 0 is plus 1. From 0 to 1 is plus 1. From 1 to 2 is plus 1. So my rate of change is constant. It's negative 2, negative 2, negative 2, 1, 1, 1. So my slope is always, always, always negative 2 over 1. And because it is constant, because it is the same, we know it is linear. So now let's look at nonlinear, the opposite end of the spectrum. So nonlinear functions are not a straight line. The x could have an exponent next to it. Could be y equals x squared or x to the third. They have these exponents. That's also nonlinear. Or they have a denominator of a fraction. So my x is on the bottom, like I'd have 1 over x, or something crazy like that. So these are all nonlinears. Remember, linears always fall in this form, y equals mx plus b. Nonlinears have crazy things going on. And last but not least, it does not have a constant rate of change. Its rate of change is changing. So example of a nonlinear could be anything with curves in it. So a common one you might see is a parabola. Now remember, this is a function because it passes the vertical line test. No matter where I draw that vertical line, it's okay. But that does not mean it's linear. Linear means line, straight line. That's not a straight line. So now, when we're looking at the table, we're looking for not a constant rate of change. So if I have my same x values, and I have y values like this, my change in x is always the same. That's good. Right? Plus 1, plus 1, plus 1. But my change in y is not always the same. To go from 8 to 19 is plus 11. To go from 19 to 20 is plus 1. To go from 20 to 24, plus 4. Now, I'm not a crazy mathematician, but I do know 11 and 1 and 4 is not constant. It's not the same. So I can say easily this is not a function. Over here, it's always the same. It's a function. Over here, it's changing. It is not a function. So guys, I have a quick little knowledge check. It's a little piece of paper the sub's going to hand out. Please complete it and check in with the sub. Make sure you got the answers right. Then you're going to complete a card sort and hang out for the day. There is an extra credit sheet on the back table that you can work on if you finish early. Please, please, please be nice to the sub. I will see you, I believe, Thursday. Have a good one, guys.